All right, Python developers, let's talk about something we've all felt. That slow, creeping dread as you watch your hard drive fill up project by project. Today, we're looking at a tool that tackles this problem head-on. It's called pepip, and its whole philosophy is built on a really simple, powerful idea.
So let's just dive right in with a question that, might hit a little too close to home for some of us. You spin up a new project, you create a virtual environment, you install all your dependencies, but have you ever really stopped to think about what's actually happening on your disk when you do that?
So here's the deal. The standard, best practice way we all work, isolating our projects with virtual environments, has a massive downside. Every single time you do this, you are downloading and storing a completely new, totally separate copy of pandas, of NumPy, or even huge packages like PyTorch. If you have 10 projects, chances are you have 10 full copies of those libraries just sitting there.
Now, that isolation is great. It keeps projects from stepping on each other's toes, for sure. But it is incredibly wasteful by design. And this isn't just a tiny inconvenience. It's a hidden cost that adds up, both in the gigabytes it eats up on your disk and in the time you spend just waiting for the same downloads to finish over and over and over again.
This slide just lays it all out, plain and simple. On the left, you've got the standard way. Let's call it the pip or UV way. Download, copy, repeat for every single project. But then look at the pepip way. It's a totally different philosophy. Download it just once. Then, for every other project, you just link to it. It does this using these tiny little things called symbolic links, or symlinks, which are basically just fancy shortcuts.
So what's the fix for this duplication nightmare? Well, let's talk about pepip. It's a tool that takes a really clever idea from the JavaScript world, specifically from a tool called pnpm, if you're familiar with that, and brings it right into our Python ecosystem. The goal is simple. Get all the benefits of project isolation with none of the waste.
And the magic behind it all is this idea of a shared package store. The best way to think about it is like having a central library on your computer just for your Python packages. When a new project needs, say, pandas, it doesn't get its own copy of the book. Nope. It just gets a library card that points to the one and only copy in the main library. And that book is immutable. It's read-only, so nobody can mess it up, which keeps everything consistent and safe.
So how does this work in practice? It's actually a super simple three-step dance. 1. The very first time you install a package, pepip downloads it and puts it in that central shared store. 2. It then creates a teeny tiny shortcut, that's our symlink, inside your project's environment. And 3, from that point on, any other project that needs that exact same package version just gets another one of those almost instant zero-space symlinks. That's it. No more re-downloading.
Okay, the theory sounds fantastic, right? But as developers, we live and die by the data. So, does it actually work? Let's get to the proof. It's time for the benchmark showdown.
And whoa, here we go. This is where it gets really interesting. This is a head-to-head comparison across 5 separate projects. With a standard installer, the disk usage was almost 475 megabytes. With pepip, look at that, just 95. That is a massive 80% drop in disk space. And it wasn't just about space, it was over 40% faster to set everything up too. Let's just put a spotlight on that number for a second. An 80% reduction in disk space. Now that was with just 5 projects, saving about 380 megabytes. But imagine you've got 10, 20 projects, or you're working with gigantic packages. The savings just start to get astronomical. And yeah, it's not just about reclaiming your hard drive. 41% less time installing, that's real time you get back. It means you're spending less time waiting and more time actually coding. Setting up a new project that shares dependencies becomes, well, basically instant.
This chart really drives the point home, doesn't it? Look at that towering bar on the left. That's the old way. That's all the duplicated data. And then, look at the little bar next to it. That's all pip needs to do the exact same job. We're not talking about a small improvement here. This is a fundamental change in efficiency.
And here's the best part. These savings just get better and better over time. The disk space savings, you feel that right away. But the time savings, that's where it really snowballs. Your first project kind of pays the one-time download fee, but after that, every other project using those same packages is pretty much free, at least in terms of download time and disk space.
Okay, so I know what you're probably thinking. This is great, but is it going to be a pain to set up? Do I have to change my whole workflow? Let's see how you actually get started with this.
And this, for me, might be the real clincher.
You don't have to learn some new, complicated system. It's a drop-in replacement. Seriously, instead of typing pip install, you just type pip install. That's it. Everything else, activating your .vms, running your code, it all stays exactly the same.
This quote from the project's own documentation just says it all, doesn't it? No more downloading Torch 5 times. Anyone who has set up multiple data science or machine learning projects has felt that pain. You know exactly what this means. This tool solves that problem, period.
So what's the big takeaway here? What should you remember? This is simply a smarter, way more efficient approach to managing Python packages. It's a simple change that saves you a ton of time and a ton of disk space. It's not about learning something complex. It's just about working smarter.
And that leaves us with a final question to chew on. You know, as our projects get bigger and huge packages become the norm, does this old model of one full copy per project even make sense anymore? Tools like pip are pointing towards a different future, and it might just be the new standard we've been waiting for.